Hi, in this video, I will be showing you problem number 42 of chapter 15, section 1. Find the volume of the solid in the first octant bounded by the cylinder z equal to 16 minus x square and the plane y equal to 5. So we are finding the volume and the surface given is a cylinder because it's a missing variable is y, so it is a cylinder, and the rulings are parallel to the y-axis because that is the missing variable. So usually the rulings will be parallel to the axis of the missing variable. In this case it is the y-axis. And the plane, so it is also intersected by the plane y equal to 5, which is a vertical plane passing through y equal to 5. The good thing about this problem is that we have to consider only the volume in the first octant. So we have to see where the cylinder intersects the x-axis, and it is bounded by the plane y equal to 5. So it is intersected by the plane y equal to 5. So we know y upper limit is fixed by y equal to 5. Then only x upper limit needs to be found out by seeing where the cylinder crosses the x-axis. So volume by the formula is integral, double integral over r, where r is a rectangle, f of xy dA, where r is the rectangle over which we consider the surface, over which we need the volume of the surface. So where does the surface cross the x-axis? This is done by setting z equal to 0. If there was y, you will set y also equal to 0. But the surface doesn't have a variable y, so we will set z equal to 0. So we get 16 minus x square equal to 0. 16 minus x square equal to 0, which means x square equal to 16 or x equal to plus or minus 4. But we can throw away the 4, negative 4, because we are considering the whole surface in the first octant that is given in the problem. We are finding the volume only in the first octant, where x and y are positive, right? Thus, 0 less than or equal to x less than or equal to 4. And also, y is lying between 0 to 5. The cylinder z equal to 16 minus x square is intersected by the plane, by the vertical plane y equal to 5. Thus, the limits for y will be 0 through 5. So we know the limits for x, we know the limits for y. So the required volume of the cylinder above the rectangle, all those x, y such that 0 less than or equal to x less than or equal to 4 and 0 less than or equal to y less than or equal to 5, it should be 5 here, is volume double integral the surface, which is 16 minus x square dx dy. It doesn't matter even if you interchange the variables because x and y are definite limits. So volume V is integral 0 to 5, 0 to 4, 16 minus x square. Because I wrote 0 to 4 as my inner limits, so I have to take only the x variable for my inner variable. The outer variable is y, dy. If we integrate with respect to x, the inner one becomes 16x minus x cube over 3 between the limit 0 and 4. Then it's integral 0 to 5, 16 times 4, which is 64, minus 16 times 64 over 3 lower limit it's 0, it's dy. Now 64 can be pulled out. So 64 times integral 0 to 5, 1 minus 1/3, which is 2/3 dy, just 64 times 2/3, integral of 1, that will be y between 0 and 5. So it becomes 128 over 3 times 5, which will be 640 divided by 3. That is the volume under the cylinder above the rectangle in this case. So this being volume, you can also write this to be cubic units. Hope this video helps.